Purification of organic compounds. Organic compounds derived from natural sources are seldom pure. They are often mixed with other substances which also occur with them. Similarly, the compounds prepared in the laboratory are generally mixed with the products which may also have been formed during the course of reaction. In order to study its properties and to determine its structure, a given substance must be first of all obtained in a state of purity. The methods employed for purification depends upon the nature of the organic compound and the impurities present in it. The process commonly used for the separation and purification of organic compounds are crystallization, sublimation, distillation, fractional crystallization, distillation under reduced pressure, steam distillation, extraction with solvents, chromatography. Crystallization. This is the process most commonly employed for the purification of solid organic compounds. The impure solid is dissolved in the minimum volume of a suitable solvent. The soluble impurities pass into solution while the insoluble ones are left behind. The hot solution is then filtered and allowed to cool undisturbed till crystallization is complete. The crystals are then separated from the mother liquor by filtration and dried. The efficiency of the process of crystallization depends on the skill with which the following steps are carried out. Choice of solvent. For a judicious choice of the solvent, about 50 mg of the solid is taken in a test tube and shaken with a few drops of the solvent. The solvent is unsuitable if whole of the solid goes into solution at room temperature. If the solid dissolves upon heating and throws out maximum crystals on cooling, the solvent is suitable. This process is repeated with solvents such as water, benzene, ether, ethyl alcohol, acetone, etc. till the most satisfactory one is sorted out. Preparation of solution. A suitable quantity of the solid substance is taken in a conical flask fitted with a reflux condenser. A small volume of the solvent selected is also placed in the flask. The quantity of the solvent should be just enough to dissolve the whole solid on boiling. The heating may be done on a water bath or wire gas according as the solvent is low boiling or high boiling. Filtration of hot solution. The hot solution obtained above is then filtered through a fluted filter paper placed in an ordinary glass funnel. If the quantity of the solution is large, it takes longer and the crystals may form in the funnel during filtration. To prevent this, a hot water funnel may be used. Separation and drying of crystals. The crystals are separated from the mother liquor by filtration. The filtration is generally effected under reduced pressure using a Buchner funnel. When the whole of the mother liquor has been drained into the filtration flask, the crystals are washed with small quantities of the pure cold solvent to remove adhering impurities. The crystals are then dried by pressing between pads of filter papers in an oven or in a vacuum desiccator. Crystallization. The hot filtrate is then allowed to cool undisturbed in a beaker. The pure solid substance separates as crystals. When a rich crop of crystals has been obtained, crystallization is complete. Sometimes crystallization does not occur even after cooling the filtrate for a sufficiently long time. In such a case, the crystallization is induced either by scratching the walls of the beaker with a glass rod or by adding a few crystals of the pure compounds to the solution. Separation and drying of crystals. The crystals are separated from the mother liquor by filtration. The filtration is generally effected under reduced pressure using a Buckner funnel. When the whole of the mother liquor has been drained into the filtration flask, the crystals are washed with small quantities of the pure cold solvent to remove adhering impurities. The crystals are then dried by pressing between pads of filter papers in an oven or in a vacuum desiccator. Fractional crystallization. The process of separating two or more crystalline solids based on the difference in their solubilities in the same solvent is called fractional crystallization. This method is employed in some cases where both or all the constituents of the mixture are soluble in the same solvent but to different degrees. If a mixture of two or more substances in solution are allowed to crystallize, for example by allowing the temperature of the solution to decrease or increase, the precipitate will contain more of the least soluble substance. Example of this is separating potassium nitrate and potassium chlorate. Sublimation. Some substances, when heated, pass directly from the solid to the vapor state without melting. The vapors, when cooled, give back the solid substance. This process, known as sublimation, is very helpful in separating volatile from non-volatile solid. It is, however, of limited application as only a few substances like naphthalene, camphor, and benzoic acid can be purified by this process. The impure substance is placed in a large beaker. The beaker is covered with a watch glass. Heat is applied gently to the beaker and the resulting vapors condense as crystals on the bottom surface of the watch glass. The watch glass can be removed after some time and the crystals collected. Organic substances such as benzoic acid, naphthalene, etc., which have high vapor pressure at temperatures below their melting points, can be sublimed relatively quickly. These can be conveniently purified by the method described. Substances which have very small vapor pressure or tend to decompose upon heating are purified by sublimation under reduced pressure. The chief features of this apparatus are a large heating and a large cooling surface with a small distance in between. This is necessary because the amount of the substance in the vapor phase is much too small in case of a substance with low vapor pressure. Distillation. The operation of distillation is employed for the purification of liquids from non-volatile impurities. The impure liquid is boiled in a flask and the vapors so formed are collected and condensed to give back the pure liquid in another vessel. The non-volatile impurities are left behind in the flask. The apparatus consists of a distillation flask fitted with a thermometer in its neck and a condenser at the side tube. The liquid to be purified is placed in the distillation flask and the thermometer so adjusted that its bulb stands just below the opening of the side tube. This ensures the correct recording of the temperature of the vapor passing over the condenser. A suitable vessel is attached to the lower end of the condenser to receive the condensed liquid. On heating the distillation flask, the thermometer first records a rise in temperature which soon becomes constant. At this point, which is the boiling temperature of the pure liquid, most of the liquid passes over. Towards the end of the operation, the temperature rises once again on account of the superheating of the vapor. The distillation is stopped at this stage and the receiver disconnected. In case of liquids having boiling points lower than 110 degrees centigrade, the water condenser is replaced by air condenser. To prevent bumping, it is customary to put a few pieces of unglazed porcelain in the distillation flask. While distilling a very volatile and inflammable liquid such as ether, the distillation flask is heated on a water bath and not on a wire gas. In case of very high boiling liquids, the flask is heated directly with a naked flame. Fractional distillation. A mixture of two or more volatile liquids can be separated by fractional distillation. When their boiling points differ by more than 40 degrees centigrade, the operation can be carried with the help of simple distillation apparatus. The more volatile liquid passes over first and it is collected in a receiver. When the temperature begins to rise for the second time, the first receiver is disconnected. A new receiver is attached as soon as the temperature becomes constant once again. Thus, the distillate is collected in fractions and the process is termed fractional distillation. Vacuum distillation. The straight distillation is suitable only for liquids which boil without decomposition at atmospheric pressure. In case of organic liquids which decompose before their boiling point is reached, the distillation is carried under reduced pressure when the liquid boils at a lower temperature. A liquid boils when its vapor pressure is equal to the atmospheric pressure. When the pressure is reduced by suction, the liquid boils at a lower temperature. The apparatus containing Gleichen flask, condenser, manometer. Gleichen flask having two necks, it is fitted with a long drawn jet dipping in the liquid to be distilled. During the distillation, a stream of bubbles rises through the capillary of this jet and prevents bumping, which is so pronounced here than in ordinary distillation. Condenser connected with a Gleichen flask on the one hand and a filtration flask serving as a receiver on the other. Manometer. The receiver flask is connected to an exhaust pump through a mercury manometer which tells the pressure under which the distillation is being carried, and a trap to eliminate any condensed liquid. The pressure in the apparatus is reduced with the help of a water pump. Whenever a lower pressure is desired, the water pump is replaced by a mercury pump. Steam distillation. Many substances that are insoluble in water and volatile in steam can be purified by distillation in a current of steam. The non-volatile impurities are left behind in the distillation flask. The impure mixture, together with some water, is placed in a round bottom flask which is then connected to a steam generator on one side and a water condenser on the other. The flask is adjusted in a slanting position so that no droplets of the mixture splash into the condenser on brisk. Boiling and bubbling of steam. The mixture in the flask is heated and then a current of steam passed into it. Heating of the flask is controlled so as to avoid unnecessary condensation of steam in it. Steam picks up the volatile substance from the mixture and passes into the condenser. The distillate collected in the receiver consists of a mixture of water and the organic substance. The distillation is stopped when the droplets or the solid particles of the organic substance cease to appear in the condenser. The distillate is then treated to recover the organic substance by a suitable method. In case it is a solid, the substance may be separated by simple filtration, and if it is a liquid, it can be removed by means of a separating funnel. The aqueous layer in both cases may be extracted with a solvent. Steam distillation is employed in industry for the recovery of various essential oils from plants